All right, so here's what we call non-removable discontinuities. This is the worst of all this entire unit. This is the stuff that is the most painful. All right, so when we say we've got a discontinuity, we've got something like a hole in the graph or an asymptote. There's some reason why we're drawing the graph and then like, oh no, there's a hole in the graph. So I have to pick my marker up while I'm drawing it. Or if you say, oh, it's got an asymptote. So I've got an asymptote, that's discontinuous because you have to stop and pick your marker up. So that's what a discontinuity is. Non-removable discontinuities are ones where we cannot fix it algebraically. We are going to have some like that, and they're a lot easier than this because this is a hassle. Basically what it amounts to when I'm doing the non-removable discontinuities, I have to graph them. I have to look at the graph. Like on this problem right here, f of x is x 1 over x minus 2. See, if you plug 2 in there, you say, wait a second, if I do a direct substitution and I get 2, I get 1 over 0. That doesn't exist. And you're thinking, wait a second, I know why this doesn't exist. Because at 2, it's got a vertical asymptote. So it doesn't exist at 2. And that's not necessarily why the limit is a problem, because holes in the graph can be a limit. We're going to get to that. But you say, so what's happening at 2? What's happening as I approach 2 on the right? What's happening as I approach 2 on the left? Well, if I start graphing this just like we used to do, and we don't have to do complete graphs on this. We can do slob graphs. You can say, well, if I plug in 3, that makes 1. If I plug in 2.5, that makes 2. And you say, wait a second, that makes one of these old guys here. So it ends up being one of these curves. And you're thinking, oh, remember this? You know, as I'm approaching 2 on the right, it's going up to infinity. So right here, approaching 2 on the right, so I'm getting infinitely closer to 2, the graph is going up to infinity. The y value is going up to infinity. So that's infinity right there. As I'm approaching 2 on the left, the graph is going downward to negative infinity. So if I'm on the left side, it's going down to -2, or I'm going down to negative infinity. So we talked about this way back when we graphed them. I'm getting infinitely close on one side. The y value is going up to infinity, infinitely close on the left side. Y is going to negative infinity. Since these are going to different values, they're not approaching the same thing. This guy, his limit does not exist. So see, that's what I'm saying. This is a hassle because we gotta graph them. There's just no way around it. So a problem like this, you say, oh, this is no big deal. If I plug in 5, oh, this is easy. If I plug in 5, I get 2 over 25 minus 5. Wait a second, I get 2 over 0. Oh, man. I got 2 over 0. That means it has an asymptote there. It's one of these guys. It's one of these guys. So you say, uh-oh. Let me see. 5 and -4 is where we have vertical asymptotes. Now, I'm going to be real lazy here. I'm going to be, and plus you can say the horizontal asymptote's at 0 because 1 over 2, so the horizontal asymptote's at 0. So, but I'm going to be, like I said, I'm going to be real lazy because I don't care about the whole graph. I only care about what's happening at 5, which is this guy. So I'm just going to ignore this. So let's do some test points. If I plug in 6, if I plug 6 in here, I get 3 over 1 times 10, so 3/10, so about right here. So I'm thinking, wait a second, if the horizontal asymptote was 0 and this point is above, then chances are it's curving up like that. Let's see if that works over here. If I plug in 4, so I'm going to plug 4 in here. 4 minus 3, 4 minus 5, and 4 plus 4. So that would be -1/8. So when I plugged in 4, I got a negative number. So I'm down here, which is I'm below the horizontal asymptote. So the curve must be doing this. So the curve must be shaped like this. And I could do more test points if I wanted to confirm that it's really, but you know this is what always happens. We just got to determine, is it going up or down as it approaches the vertical asymptote? We've done this a million times. Okay, that's an exaggeration. We've done this a bunch of times. We had a unit test on it. So it's going opposite directions at 5, so limit does not exist. On the left side, it's going down to negative infinity. On the right side, it's going up to positive infinity. So anyway, that's what's annoying about these problems. We have to do these graphs to see what's happening. And these are vertical asymptotes. And in fact, all these problems are vertical asymptotes. This entire section is vertical asymptotes. And you're saying, oh, this is oh, wait a second. I got to remember my trig graphs. I got to remember what tangent looks like. Well, good old tangent. Remember how good old tangent had asymptotes at pi over 2 and negative pi over 2. So good old tangent looked like this. Good old tangent was like this. Okay. And you're saying, oh, well, I just care about what's happening at pi over 2. Well, here's tangent at pi over 2. On the left, it's going up. So on the left, it's going up. On the right, it's going down to negative infinity. Since it's going different directions, we would say the limit does not exist. But unfortunately, you're saying, oh, man, I got to remember this stuff, don't I? You're right. Cosecant, pi over 2, you're going to be like, oh, man. So I got to do negative cosecant 2 times pi over 2. So that equals negative cosecant. All right. So when we're doing this negative cosecant here, you're saying, okay, so clean that up. Oh, that's just negative cosecant of pi. And then you're like, uh-oh, pi is way down here. And you're thinking, good old, let me see, good old cosecant graph is based on sine. And sine looks like this. Whoops, that was negative sine. Point being, since this is negative cosecant and this is negative, so we really need a negative sign here. So here's my asymptote for the pi, and you're saying, but that's pi, because when we plugged in pi over 2, that's what we got. Remember how this would change the period? It would condense it. So if we put pi over 2, this is just an easy way to do it. But yeah, I see what you're saying. If we can, this is really saying it's got a period change, and the period's just a pi over 2, not period change. When it's shrunk. Anyway, where was I? Yeah, whatever. So anyway, on the left side, it's going down to negative infinity. On the right side, it's going up to positive infinity. So these are different, so limit does not exist. So one more time, the thing that's annoying about these is they're going different directions, or it's it's vertical asymptotes, and we have to be careful about these because we unfortunately have to look at the graphs. So these are the most annoying problems of the entire unit.